So why do the data scientists fear the curse of dimensionality? Before telling you this, I want to convey the what COD or curse of dimensionality actually means. So imagine, uh, I will first write out the definition. So curse of dimensionality or COD means that the accuracy of the model. Uh, Accuracy is a generalized term here. I mean to say the performance of any machine learning model or any type of machine learning or deep learning or any type of AI model decreases if number of features increases beyond a certain threshold. So I know this definition is a bit confusing. That why will the accuracy drop if the number of features, the amount of information is being increased given to the machine learning model? I will like to show you this with an example. So what I mean to say is, imagine that you are working in a hospital, okay, and you have to predict whether a person is diabetic or not. If the person is diabetic, you will give it a class 0. If it's not diabetic, you will give a class of, sorry, if it's diabetic, class of 1. If it's not diabetic, class of 0. And data set that you are given by the doctors are, you are given different type of features that is age, then you are given the hemoglobin level, then you are given the cholesterol level, and so on and so forth. So right now you have three features, right? So one person might have an age of 50, hemoglobin level, let's say it is a scalar value and it's 2, and the cholesterol level is 3. The person is at 30 years of age, his hemoglobin level is 3 and cholesterol level is 2, and here it is class 1, here it's class 0, and the person is diabetic or not. Okay, so this is the data set you're given. Now if if the amount of features, now what are the features that are using? Age, hemoglobin level, and the cholesterol level, right? So we increase the amount of data, increase the dimensionality, increase the number of features. So you imagine we include age, hemoglobin, and cholesterol level 1, where cholesterol level 1 is cholesterol of that person when he was checked in month 1, then cholesterol level 2 when he was checked in month 2, then cholesterol level 3 when he's checked in month 3, and so on and so forth. So this is just a dummy feature I'm telling. So imagine if we increase the dimensionality of a data set like this. So what happens now? The same person. Imagine if we have if we have a data point like this, 52 3, and another data point of same 50 or with some variation, 52 and 3.1. Here the person was being given a class 1, and here the person was given a class 0. That is the same person with same age, same hemoglobin level, but different cholesterol level. One was being diabetic and with a minimum variation. Another was telling it to be non-diabetic. So how will the machine learning model or the logistic regression classify it? It's a confusing data point, right? So if we increase the dimension of the data set like this, we will have more amount of information. For example, beyond 3, if this person might have cholesterol level 2 at 2.9 and cholesterol level 3, cholesterol level 2 for the second person might be, for example, 4.2, then we can certainly say that its cholesterol level is 0 because its cholesterol level 2 is higher. So from this old amount of features, old 3 features, this information was not being conveyed. That why these are two different classes. But when we increase the dimension of dataset and use more information, more new information, it became clear that why the person was being classified as 1, another person was being classified as 0, non-diabetic. So here you can see that using more amount of features is very good. Like it's giving a more amount of information and more amount, better confidence in prediction. But the problem arises here. Imagine you have the same person 52, 3 and 4.2 and 52, 3.1 and 2.1 or something. So here it's class 1, here it's class 0. So here is some hypothesis being formed that okay, even if the initial 3 features are same, but this cholesterol features is different, then one can be and it's if it's greater than 3, then give up. class value of 1, otherwise it's less than 3, then class value of 0. But you see, the same hypothesis might be broken somewhere else in the data set. No, here it might happen that a person with some different variations in the hemoglobin level 2.1, same cholesterol level 1, and same cholesterol level 2, 2.1, might be given a class of 1. Now, if you might have focused on these three features alone, due to this little variations also, the machine learning model would have performed better due to this less amount of features. But seeing these two extra feature, but using this extra feature, now what I mean to say is using the old three features, the model would have performed better because it would have used it would be less confused. But when you incorporate the third feature, the model has become more confused. That the previous hypothesis being formed here, that less than 3 or greater than 3 is good for class prediction, is broken here. So this happens very often in the dataset when the dimensionality of the dataset increases. Now you know why. As you increase them, just try to relate with your own life. The more information you are given, the more confused you become. Like talking to different people. When you want an advice, you usually talk to two or three trusted sources. But when you try to talk to everyone, you become more and more confused. It's the same way. When you talk to more people, you become more confused. But when you talk to only two or three people, you are more confident in your work. So it's the same way. As the information increases, as the number of features increases, your confidence in prediction drops, your accuracy drops. This is called the curse of dimensionality. Dimensionality means the number of features. This is the accuracy or the performance of the model, and this is the number of features or dimensionality in the dataset. So as it increases, the model performance or accuracy rises, but only till a certain number of features. Like for example, it was 3 here. But after that, as more and more information comes, the accuracy drops. This is known as curse of dimensionality. Simple and most forward way. And another beautiful thing that I noted about curse of dimensionality while I was reading about this in machine learning 2 to 3 years back was that it makes the model overfitting on the training data set. And there is a beautiful explanation of this. Now imagine you have a three-dimensional data set. Like let's say you have three-dimensional data set. I will take the hospital example only 52 and 52 3, and another data point is 52 3 and 52 0, let's assume. Another data point is 52 5. So the first data point 1 and 2, 1 will lie somewhere here because that coordinate is 0. Another data point will lie just above this at a distance of 5, right? Because only z coordinates differ. No, because the data points are nothing but just what, a form of vector which can be plotted in the n dimension space. Here the dimension is 3. So this is the x, y, and z axis. Now imagine you are sitting right here and looking at this data set. So this is the first data point, this is the second data, sorry, this is the first data point, this is the second data point, right? Now if you will see it from the top, what will you see? In this point of view, in the two-dimensional point of view, you will see only one dot because the second dot is being overlapped here. So but you know that 1 and 2 are in this plane only. So in the two dimension, the distance between 1 and 2 is how much? The distance between point 1 and 2 is 0, right? But in three dimension, when you look, you know the distance between them is what? 5, 5 units, right? So what you are observing here, as the dimension increased, the distance between the data points also increased. Though both the data points were situated in the same way in any dimension, even if you look in 4 dimension, they were situated in the same way. In 2 dimension also, they are situated in the same way, but only the point of view differ. So as we increase the number of dimension in the data set, as we increase the number of dimension in our point of view, the distance between the same data points increase. And what problem does it create? If the data points become more and more spatial in nature, they become more and more sparse. And you know, if the data points are concentrated in a particular region, the machine learning model can easily fit a linear decision boundary, any type of decision boundary. But as it becomes sparse, it becomes more and more noisy and more random, and it becomes difficult for the machine learning model to put a hyperplane through all of this. It actually goes through a manifold, but we will learn it later. So this is the main problem of cursor dimensionality. It machine learning models becomes overfitting on the training data set because the data set becomes sparse, more more spaced. So this is another reason that why COT leads to decrease in the performance of model as we increase the number of features, as we increase the dimensionality of the data set. So, and that's why we move to the PCA, principal component analysis, or another feature importances method or feature extraction techniques to decrease the dimensionality of the data set. So this problem does not arise. Thank you.